So if you want to compare a series to a p-series, that helps us out because we know that p-series are convergent as long as the power is greater than 1. So like this one is not convergent. This is a harmonic p-series. This is divergent. But all these other ones converge. Okay. And what helps us is that like if we can say that this expression is always going to be less than one of these, and if this converges, then we know that this is going to converge as well. Okay. So let's see. Sine of 6n. Let's think about what we know about sine. Sine alternates between positive 1 and negative 1. So the highest possible value that this could be would be positive 1. And the lowest possible value this could be is negative 1. Otherwise, it's somewhere in between. If the amplitude was different, then we'd have a problem because then we'd be going up to positive 2 down to negative 2. So it wouldn't be as easy to compare to a p-series. Okay, so we know that this is always going to be less than or equal to 1. So that's good with the numerators for making a comparison. And we know that this expression is always going to be something smaller than this expression because this value could be 0.5, could be 0.2, something like that, right? So it's always going to be smaller or equal to 1. So since we know that this is a p-series that converges, and since we know that this expression is always going to be something smaller or equal to this expression, then we can say that this converges by the comparison test. So this is the expression we want to compare it to. Okay, this one's a bit more complicated. We have n in the numerator, n to the fourth plus n to the third plus n in the denominator. So when we're talking about a series that goes from n equals 1 to infinity, what really matters is the end behavior of the expression. These terms become infinitesimally insignificant because as you get bigger and bigger numbers, n to the fourth is going to outpace n to the third. You might remember that from Calc 1, studying end behavior, maybe pre-Calc 2. So the term that really matters is this term up front, and we have an n to the fourth and an n to the first in the top power. So the end behavior of the model is going to be something like this, 3n to the third. I said end behavior of the model. Sorry, I'm teaching stats at the same time. So the end behavior of this expression is approximating 1 over 3n to the third. So which one can we compare this to? This has a power of third in the denominator. The tricky thing, yeah, we can always say that this expression is less than or equal to this expression. Because if you just forget about this 3, they're exactly the same. If you put that 3 in there, now you're dividing by an even bigger number in the denominator. So this expression is always going to be smaller than this expression. Okay, so we could say this converges by the comparison test of the p-series and its n to the third power for the end behavior reasoning I gave above.